All right, in this video, we want to review how to find a least common multiple, or the LCM. So most of us remember how to find an LCM of just constants, right? Just numbers. So remember the way we would do that, we're going to write down all of the multiples of that number. Okay, so if I'm trying to compare the numbers 3 and the numbers 4 to find the least common multiple, I'd list all the multiples of 3. So we've listed some here. Then I'd list all the multiples of 4. We've listed them here. Remembering that the least common multiple cannot be 0. So even though 0 is on both of these, 0 cannot be the least common multiple. So the actual least common multiple between these would be 12. Even though 24 is a shared multiple, remember we want the least of those. All right, so it's a little review on just constants or just numbers. All right, so then what does that mean for variables? So let's take a look. I can look at variables kind of in two ways. Okay, I can look at when I have a monomial. Remember, a monomial means that I do not have any addition or subtraction. I only have one term. Okay, so when I have one term and I want to compare it to another monomial or another expression with one term, what I want to do to find the least common multiple, I'm going to find the least common multiple of the constants, so the numbers 4 and the number 6. And then I want to find the highest exponent of each of the variables. So in this example, we've got the numbers 4 and the number 6. So I can list out the numbers if I need to, or I can think about what the different multiples would be, right? So I know that 4, I could have 2 times 2, and 6, I could have 3 times 2. So when I look at that, this is what we call the prime factorization. So I'm breaking down those numbers, those constants, into their prime numbers or their prime multiples. All right, so since 4 is equal to 2 times 2, and 2 is a prime number, 6 is equal to 3 times 2, and 3 and 2 are both prime numbers. Okay, so once we've done that, we're going to find that least common multiple. Okay, so when I'm looking at this, I want to basically write down the numbers that we would need to have to get to 6. All right, so I would need a 2. I would need this 3, and I would need this 2. Okay, that's how we do it with prime factorization. Although you could do this the same way that we just did a minute ago. I could list out the factors of 4, 0, 4, 8, 12, 16, 20, 24. And then, right, I could keep going. I could list out the number or the multiples of 6. So 0, 6, 12. And I can actually stop there because I notice that I have my least common multiple here is 12, which is the same thing that I get when I multiply 2 times 3 times 2. So I can do this with the prime factorization like they're showing here, or I can do the same way that we just did, listing out the values. Either way, I want to come up with my least common multiple. Okay, so we saw a new way. This was what we called the prime factorization. And the reason I want to show this prime factorization, because that is how we're going to actually deal with our exponents. Okay, so when we look at our exponents, we want to look at the variable that they share. Okay, we have to have every variable listed, and then we also have to have the highest exponent. Okay, so I don't need to write an x down twice because it's shared, but I do need to have the highest exponent, so I would keep the x to the 4th. Okay, I see that I also have a y, and I want to keep the highest, which would be my y to the 5th. So putting that all together, I'm going to keep my 12. I'm going to keep my x to the 4th. I'm going to keep my y to the 5th. So I get that least common multiple. Okay. Now, let's say, for example, instead we had a binomial, a trinomial, or just a polynomial, right? So I actually now see addition or subtraction. Okay, the steps are similar, but they start off a little bit different. Okay, so I still want to know what I would need to multiply by, right? Just like we had in the last one. But the way I did that in the last problem is that I either wrote out the multiples or I came up with the prime factorization. Here instead, what we want to do is we want to factor. Okay, so we're going to factor each of those expressions. So factoring my first expression, we get x minus 3 times x plus 1. Factoring our second example here, we get x minus 3 times x plus 2. So the least common multiple, I need all of the factors, but if it's shared, I only need it once. So I need for sure an x minus 3, okay? That's going to take off both of those because it's shared, so I list it once. I also need an x plus 1, and I need an x plus 2, okay? So remember, this x minus 3, I'm only going to have it on there one time. So I'm going to have my least common multiple is all three of those shared factors. Okay. One thing to also remember, because these are factors, remember the word in general, factor, means that I want to multiply these. So one thing that I notice is up here we multiplied the 12 times the x fourth times the x fifth. Here we multiplied the x minus 3 times the x plus 1 times the x plus 2. Okay, so when we come up with this least common multiple, we want to multiply the different factors. Okay, so let's look at some examples from the very beginning and let's work them all the way out. All right, so looking at this first example, I want to start off with my constant. So I'm going to look at 3 and I'm going to look at 18. And honestly, I'm the type of person that likes to write out the multiples. I'm not so much of a prime factorization person. So I'll do it both ways so that we can see what's happening. But I'm going to write out the multiples of 3. So I've got 0, 3, 6, 9, 12, 15, 18, right? And I could keep going if I needed to. And then I'm going to write the factors of 18. 0, 18. Now I can stop because I already see the least common multiple. Okay, so I'm going to start building this least common multiple here. Right now, so far we've got our 18. Right now I'm going to move to my variables. So with my variables, what I'm going to look at is I need every variable included. So I'm going to need x's and I'm going to need y's because those are the two variables that I have, right? So then I'm going to need to keep the highest exponent. So if I look at my x's here, I've got an x3 and an x4. I'm going to keep the highest exponent, so it'd be x4. And my y4 and my y2, I'm going to keep the highest exponent, so it would be y4. So my least common multiple is 18 times x to the fourth times y to the fourth. All right? So let's see if we can do the next one. This next one, I'm going to do this with prime factorization, so you can see that way too in case that's the way that you like. Okay, so I'm going to do that. I'm going to start off with my 27. 27 can be written as 3 times 3 times 3. Okay, those are all prime numbers, so it works. So 36 can be written as 3 times 3 times 2 times 2. All right, because 3 times 3 is 9, 9 times 2 is 18, 18 times 2 is 36. All right, so I've written out all the prime factors. Okay. Now what I can do is I can say, okay, well, I'm going to need one of these sets of 3s. I'm going to need one of these sets of 3s. Okay. Then I'm going to need this set of 2s. Then I'm going to need that last 3 that I haven't used yet. Okay. So 3 times 3 is 9. 9 times 2 is going to be 18. 18 times 2 is 36. 36 times 3 is 108. Okay. Now, again, I'm not a big fan of this method. However, it is definitely one of the ways. So let me show you if I was doing my list of multiples and you can kind of decide which way you like better. So let's say I was listing out my multiples. So I'm going to list out my multiples of 27 here. So I've got 0, 27, 54, 81, 108. All right. And I can list some more if when I start to list 36, I don't find anything. So we'll leave that one for a second. So I'm going to start with 36. So I got 0, 36, 72, 108. Now I see that my least common multiple is 108. So again, those are two ways that we could do this, whichever way you like the best. So my least common multiple, I'm going to start with 108. Then I'm going to look at my variables. I see that I have an x. I see that I have a y. Now I need to come back and figure out what is the highest exponent connected to those variables. So I see I've got an x to the first power and an x squared. So I'm going to keep that x squared. I've got a y squared and a y to the fifth. So I'm going to keep the y to the fifth. All right, so that's going to be my least common multiple. Right? All right, now we're going to switch gears and we are going to look at being able to come up with our least common multiple when we have polynomials. Okay, remember our steps was that we were going to factor them first. So I'm going to look at my first expression here. I'm going to factor this. All right, so I'm going to come up with x plus 1 times x plus 4. All right, now I'm going to factor my second expression. And if I had 3 expressions, 4 expressions, 5, however many expressions I have, I'm going to factor those first. So I'm going to have x plus 1 and x minus 9. All right. So now to get my least common multiple, remember I'm going to list all of the factors. If they share it, I just list it one time. So I only need to write the x plus 1 one time. Then I need my x plus 4. And then I need my x minus 9. And that's going to be my least common multiple. Okay, so I think this one's actually kind of easier as long as we're good at factoring. I'm telling you what, that factoring is not going away. It will be here on almost everything we do. We really got to know how to factor. Okay, looking at our last example here, we want to factor our first expression. So the first thing that I see is I've got a GCF. They can both divide by 2 and an x, which is going to leave me with an x plus 5. All right. Looking at my next expression, I'm going to first notice that I do have a GCF. So I'm going to first divide off an x, which is going to leave me with 3x squared plus 16x plus 5. Then I'm going to finish factoring this here because I'm not finished here. So that's actually going to become 3x plus 1 and x plus 5. All right. So now when I'm looking at my factors, I'm just going to kind of squiggle through this one because I don't want to accidentally look at that one. Okay. So I've got my factors here. I first start off needing to have that 2 because there's no other constant, so I need that 2. Then I notice, okay, I've got an x here, so I need a variable. They're both exactly the same, so it doesn't matter which one I pick, it's just going to be an x, right? If one was an x cubed and one was an x, I'd take the x cubed, right, the higher of the two. Right, now I need to list my factors. So I have a 3x plus 1 that I need. And I only need to write that x plus 5 one time. Right, so my LCM would be all of this here. All right, so now hopefully we've reviewed how to find a least common multiple when we have constants, when we have variables, when we have monomials, when we have polynomials, right? So hopefully we can be able to find those least common multiples.